Hi, everyone. We're going to talk about respiratory, and this is very fitting since the coronavirus and COVID-19 is happening. So respiratory, respiration, we're talking about breathing, yeah? So we're talking about the lungs, all the air passageways, and then to the lungs. So we'll do some anatomy, we'll do a little bit of physiology, and then get into the medical terminology. All right, so we're going to describe respiration, of primary functions, organs, physiologists, yeah, terminology, medical words, drugs. Okay, so again, it's scratching at the surface. All right, so some tests. Yes. Okay, so if we're looking at the anatomy, nose, pharynx, right? That's a throat, larynx. That's we're like right on top of the trachea. Trachea, your air tube, bronchi, where the trachea splits, and then the lungs. The lungs are really a bunch of things. They're blood vessels, nerves, and then there are all these passageways, and then air sacs, the alveoli. So what is the main function? Okay, that's pretty easy. It's gas in, gas out, yeah? And we can look at respiration as the physical act of taking air in and air out. And then when we get to the alveoli, there's the air that's going into the blood and air coming out, right? So respiratory system's primary function, O2 in, for use of individual tissues. Okay, so we need oxygen for energy. And then there's waste products, and carbon dioxide is a waste product, so we're going to exhale it. So external respiration, that's the actual breathing. Okay. And then in the book, right, they say internal respiration. So that's the actual physical gas exchange between the air sacs in the lungs and then into the blood. Okay. So this is a beautiful picture. We can see, right, nose, nasal cavity. Here's the oral cavity. So here's the pharynx, really the throat. And again, doctors who specialize in this area are called ENTs, ear, nose, and throat, because those things are all connected. And then here, right, we have the larynx, right? The epiglottis is over here. And then the trachea is the windpipe. So you can see the windpipe here. And then that's going to divide into the bronchi. And then they divide. It's called like secondary, tertiary bronchi, and branch into the tiniest little branches. And eventually we get to the air sacs, and those are the alveoli. And the actual gas exchange is from the air here into the blood. O2 from the air into the blood, CO2 from the blood out. And then so inhalation, exhalation. And here's the diaphragm, this dome-shaped muscle, and its whole job is to help us with breathing. The diaphragm, and you have what are called your intercostals. They're going to help with breathing too. All right, so that shows what we just talked about. So cartilage, right? So the nose, you do have cartilage at the top, right? This is cartilage here, the bones over here. Inside, when the air travels, there are all these, they're called conchae, and they look like conch shells, and they go like this, and there's mucus around them, and that kind of warms the air and filters the air, and moistens the air before it gets to your lungs. Okay. So mucous membrane with cilia. The cilia are going to help trap and get rid of junk. Smell receptors, yes. At the top, okay, you actually have neurons. That's for smelling. And they're actual chemoreceptors, so chemicals in the air that you breathe. They're going to stimulate those neurons, and it's going to take that information to the brain. Sinuses, 4 pairs of paranasal right around next to the sinuses. So truly, sometimes people get sinus headaches, right? And so here, right, your frontal bone here, and so you have frontal sinus. Now here, ethmoid, There's sphenoid and then maxillary. So there are mucous membranes around here. These areas can get inflamed, and that can cause pressure, and that can cause pain. And these sinuses actually do drain into the nasal cavity. So if we go there, drain right into the nose. And so there's passageway. So if you have an infection, the infection can travel into the sinuses and can cause a lot of pain and discomfort. Cleft palate, you may have heard that, right? If these bones, this is the hard palate in the maxilla, if they don't fuse, that's a cleft palate. And it's like, okay, what's the big deal? It's just, the big deal is, think of a baby. A baby needs to suck, right, to drink milk. And if that palate's not fused, now they're going to have a hard time drinking milk, and that's a problem. 1 in 700 live births. Believe that? That sounds like a lot, honestly. And it could be, minimal, or it could be severe. Can lead to problems with eating, talking, ear infections. And then there are multiple surgeries that they'd have to go through to fix that. Pharynx, right? This tube, the nasopharynx, oropharynx, laryngopharynx, we're talking about the throat. 7 openings, yes, the eustachian tubes. So these are the tubes from the ear, and they would lead to the throat. So sometimes, you're sick and you can get an ear infection. Well, yes, because the bacteria can go into the middle ear and can cause an infection there. And so we have middle ear infections. So openings of the nose, of course, the mouth, the larynx, esophagus. So there are lymph nodes around there. We hear of the adenoids, the tonsils. They're going to aid in filtering bacteria, other foreign substances from circulating lymph, right? So it's going to be a protective ring around the throat. This is a beautiful picture because this is a sagittal section. So here's the mouth, right? Here's the tongue. Here's the jaw, right? So here is the oropharynx, okay? The nose, right? Here, there's an opening. Let me see, they don't have it labeled. But the opening to the ear, the eustachian tube, would be in this area. Now here, the air would go down. Food, you chew, it would go down into the esophagus. Air is going to travel down into the trachea. And if you look at the trachea, it's anterior to the esophagus, right? Here's the epiglottis. This is almost like a little trap door. And when you swallow, it goes whoop, right? Covers this up. And then the food can only go this way. But when you're not eating, the air is going to be going this way. Air can go into the digestive tract also. That's what causes gas and burping and all of that. If you look, right, so here is the pharynx, here is the larynx, and your voice box, your vocal cords are here, okay? So larynx, voice box. Okay, you have the false vocal cords, true vocal cords. We have cartilage in this area, thyroid cartilage, epiglottis, right? There it is, acts as a lid to prevent aspiration of food. Okay. All right, so trachea. Trachea is our windpipe. Now, it is not, I repeat, it is not a hollow muscular tube. You don't want it to be hollow. If it's hollow, it's going to collapse, right? So there are these cartilaginous rings. They almost look like C's, but they go this way, okay? And they're going to hold that trachea open. So about 1 inch wide, 4.5 inches long. So C-shaped rings, right? There's mucus. There are cilia. So those little hair-like extensions on the cells, they're going to beat upwards to move stuff up and out. Because if stuff goes down and it goes to the lungs, that's a dead end, and you don't want that to happen. So you have mucus to help trap foreign particles. You have the cilia to beat upwards to get rid of the foreign particles. And imagine if you go outside and it's really dusty, you start coughing, right? Right, you coughing, you're trying to get that stuff out of your respiratory tract because you don't want it to get into your lungs. So trachea is going to branch into the bronchi, 2 main branches of the trachea. They're going to have cartilage around them too. Bronchi, smaller bronchi, bronchioles, alveolar ducts, okay? And eventually we get to the tiniest little air sacs of the lungs. They're called the alveoli. Alveolus is singular, alveoli are plural. Tiny air sacs supporting a network of capillaries. Okay, so let's look. Let's go there. Oh, lungs. The lungs are really going to be all of that stuff. The lung almost looks like an upside down tree. So there are all these passages and then they dead end in the alveoli. So it's passages and air, but then there has to be blood. There's a lot of blood flow there because the oxygen has to diffuse into the blood vessels, the capillaries. So lungs are enclosed in pleura. There are membranes surrounding the lungs, serous membrane, pleural cavity, the space between, okay, diaphragm, mediastinum, okay. With age, what happens? So, you know, we hear about the coronavirus, and I'm going to have a video. I'm going to have a couple of videos for you that I'd like you to look at. One talks about the virus itself and how does it work and how did it evolve. The other one talks about, well, what happens? Why, unfortunately, why do people die? Okay, what is actually happening? It's really the immune system trying to fight off that virus, and then an accumulation of fluid. And the alveoli, right? If there's too much fluid, now the oxygen can't diffuse to get into the bloodstream. And if it can't get into the bloodstream, literally the person suffocates, okay? So it says, what happens as we get older? Why are older people more susceptible, right? With advancing age, the respiratory system is vulnerable to injuries caused by infections, environmental pollutants, allergic reactions. The number of cilia decline, the little hair-like things, they decline, so we don't have that help to get stuff out of there. Number of mucus-producing cells may increase. So if there's too much mucus, that could become problematic. Another change that can occur in composition of connective tissues, lungs become stiffer, right? So they're not like as spongy, as easily moving. Respiratory muscle strength and endurance diminishes. Chest wall becomes more rigid. So now it's not as flexible. And so with coughing and so on, it's harder to get stuff out of there. And then there's more mucus. Also, vital capacity. Now, we haven't talked about this yet, but this is talking about actual physical lung volumes, like air volumes that go in and go out. Vital capacity decreases because residual volume increases. So the lungs are going to hold on to more air, okay? Amount of air remaining in the lungs after maximal expiration. So we're going to talk about that. That gets into physiology, this idea of tidal volume, respiratory volume, expiratory reserve, inspiratory reserve, and so on. So the lungs themselves, the right side versus the left, the right has 3 lobes, the left has 2. It's better to see a picture, right? Here's the picture. Here are the 2 on the left side. Here are the 3 on the right side. And the left side does have a little, there. It's called a cardiac notch, right? Because the heart's kind of tilted to the left there. And so there's that little groove. Okay, so they're talking about babies, they're talking about gestation and what actually happens with the respiratory system. I don't know if you guys know this. With kids, with a fetus, a growing embryo, and then a fetus, the last system to develop is the respiratory. And specifically, there's this stuff called surfactant. And so imagine the alveoli. Okay, they're little air sacs. There's fluid here. And imagine if you had a plastic bag. If you had a plastic bag and you had fluid, the walls want to stick, okay? Same thing with the alveoli. The walls want to stick. Well, the cells will make this stuff called surfactant, and it keeps it from sticking. Now, if a baby's born prematurely, their cells aren't making that surfactant. So their lungs can collapse, okay, and they can die from that. Now, we've learned about that, and so we can make surfactant, and we can actually give newborns, especially preemies, not newborns. It would be premature babies. We can give them surfactant. All right, so surfactant is produced, right? So that's respiratory distress syndrome. Of course, when a baby's inside the uterus, the baby's not using its lungs, right? And the fetus, I should say. The mom is, and the gas exchange is happening in the placenta. All right, we're going to stop here, and then we'll start up in just a sec.